Hey everybody, this is Ray with Ray Does Data, and this is my first portfolio project. Welcome. Going to be looking at some U.S. baby name trends over the course of 3 decades, 1980 to 2010 to be exact. But before I start, just want to acknowledge that the data set that I'm using today is going to be coming from Maven Analytics, a really cool platform. It's been a great resource to me, not only to learn my tools, but also practice them. Case in point, this project right here. So on that note, let's go ahead and get started. What we're looking at right here are the queries that I've done on VS Code. Just going to just start with creating some tables. Got the names table, regions table. Going to load it up with these columns right here. I have state, gender, name, births, and then the regions table. It would state and region there. I'm going to walk you through the process of loading. Basically, what I did to load the data into those tables, just because we're dealing with some pretty large files here. So I wasn't able to just upload them using SQL. I had to switch to Python for this bit. Because I had a little bit of an error, which you can see around step 3 here, which is that the CSV file had a break in it, and one of the values was not in quotes, and that's over 2 million lines of data in that CSV, so obviously not going to go through that by hand. So what I did was actually create a Python file, which we can see briefly here. All of this is basically saying is that I've loaded the CSV here, or imported pandas. That was the first thing. And then I had pandas read that file. I formatted it with all the columns that I wanted to use, compared against the original total rows versus the loaded rows that I imported. And then I created a new path, saved the clean file to the new path, and then saved the new path as a clean path to the data. And after all that, I was able to use a copy command to load the CSVs into Postgres. No trouble there. Only thing left to do now is to insert some values into the regions table so that I can reference that later. Exactly what it looks like here. I have states and their location regionally in the country. And on that note, we're going to move on to the first objective, which is to track changes in name popularity. Brings us to the first question, which would be to find the overall most popular boy and girl names and to show how they've changed in popularity rankings over the years. So first thing I'm going to do is start with a common table expression, which I'm going to refer to as a CTE from now on, which would be the year name totals. So I'm basically just saying that year name totals are going to be selected from year, gender, name, the sum of the births as total births. All that's going to come from the names table, and I'm going to group by year, gender, and name. And then I'm going to have some rank names coming from this query here. And you'll notice that I used rank. That's going to be it's going to be pretty popular throughout the course of the queries that I'm going to show you. It's going to be partitioned by year and gender and order by total births. Just so I can get the most popular name per gender is the main goal of that there. And then this final outer query is going to track the last part of the question, which is going to be tracking the changes over time. And I'm just going to go ahead and show you what that looks like in the end. I've got to run that here. Make some space for us. Right. So to find the overall boy and girl names over the years and track how they've changed, we're going to start with the beginning of the data set, which is going to be 1980. And this is basically showing us all the most popular girl names for that year. And we're going through the entire data set, right? So all 2 million rows, which is, you can see right there, all 2 million rows to show you how each girl name is going to be ranked over the course of the year of 1980. Now you can see how that's iterated upon once we make it to the end of one year and the beginning of another. And now we're starting over fresh with a new set of ranking. Question 2. Find the names with the biggest jump in popularity from the first year of the data to the last year. Not too different an approach here. Basically just going to start with summing the birth names, or the births per name, I should say, gender and year. I'm going to use a first last year's. So that's basically, I'm going to use a conditional aggregation here to get the total births for each name in the first and last year only, right? Which is going to bring us to our third CTE, which is going to be used to track the popularity change. So I just want to note the difference in birth between the first year and the last year. And then this last select is going to be an absolute change. So my goal with that is to get the biggest changes in popularity. So I'm going to go ahead and show y'all what that looks like too. And yeah, I know I'm on the long way and there's a shortcut, but for some reason my machine isn't taking the shortcuts right now. So I'm going to go the long way. And now look at it. Yeah, so these are the names with the largest jumps from the first year to the last year. So that's super cool. That does it for the second question and the first objective. So let's go ahead and move on to objective 2, which would be to compare popularity across decades. So this first question, for each year, return the 3 most popular girl names and the 3 most popular boy names. It's pretty straightforward. This rank name CTE is basically going to group your gender and name with that first select. And then I want to sum the ranks and the births within each year and gender group. So to do that, I'm going to use the rank command again. Then there's that final select where I would filter for names that are greater than or equal to 3 so as to accommodate the 3 most popular names for each gender. And let's go ahead and show y'all what that looks like. Alrighty. So you'll see here we have 3 gender F, 3 gender male for 1980. So that's 6 entries for 1980, another 6 entries for 81, and so on and so forth. And then we have the rank for each name as it relates to the gender there. Success. This next question is pretty similar. But instead of going by year, we're just going to go by the decade. So I pretty much, again, it's not too different from that first bit there. The only thing really that I added was this, just so I would be able to transform the year into a decade range. Instead of going 1980, 1981, 2, 3, 4, I'm just going to group it into the 1980 decade, the 1990 decade, and then the 2000 decade. And I'm going to show you guys what that looks like. Sweet. And then we have 6 entries for that as well, 3 for each gender. And then the rank still applies, but like I said, we're just grouping it by 1980, 1990, and then 2000. So that's cool. Next, I'm going to move on to the objective 3, which is going to be to compare popularity across regions. I had a lot of fun with this one. This was my first time in a while doing joins, so it was good to brush up on that. Going to start with a simple join between the names table and the regions table, and I'm going to use the common column of state to do that. And I'm basically going to aggregate bursts by the region. That's what we have going on with the sums as total bursts in that instance. And then I'm going to order the total bursts so that I can, order the total bursts. So I can see which region had the most bursts. This one's cool, was quick and easy. A little bit of thinking for the joins just because it's been a while for me, but I think it worked out okay. So this is going by year, and then it's breaking it down by gender as well. So each year has 2 entries, one for male births and one for female births. And then we do that all the way through until we get to 2009. And then we switch over to the next region. That looks good to me. So, next question then. I'm going to return the 3 most popular girl names and the 3 most popular boy names inside of each region per year. So now we're getting into some more layered queries, effectively 2-parter a little bit, because it's asking for most popular per region, and then I'm going to have to break that down per year. So I'm going to join names with regions again using that common state column. I'm going to use rank and partition by region and gender, and then order by the sum of the births there, so that I can filter for one region if need be, and then I can also add filters down the line. So this one's really cool. Oh yeah, there's that final select there. And then we have the filter for the 3 most popular and then order by. So this one's really cool just because it's super modular, and depending on what questions or how the question may change down the line, it's pretty easy to swap out or replace certain factors, certain commands and CTEs and things like that. So I really like that one just because even though it's a little bit longer, I think it's really scalable. So now we have the region, 3 most popular girl names for the region, and then the rank, boy names, and that's it for 1980. And then all these are going to be the most popular in the Mid-Atlantic. And then that's going to go on for until 2009 again. Yeah. And then we'll switch over to the Midwest and do the same thing, basically starting from 1980, where we have the 3 most popular girl names and their rank, 3 most popular boy names, rank, and then 1981. So that worked out well. That brings us to our next objective, which is going to be exploring some unique names. We're going to start by finding the 10 most popular androgynous names. That's going to be names that are shared with both males and females. I'm going to start with the the rank names. So obviously I want this to be the most popular, as the question states, the most popular androgynous name. So I'm going to call that ranked. So we're going to go in order from that, and I'm going to pick the names, the gender. I'm going to have it aggregate the sum of the births. I'm going to have that register as total births. That's going to come from the names table. I'm going to group them by name and gender. This one was fun because I got to use the pivoted command. I don't do that very often. If you recall, though, from the previous result that we saw, the males and females results were kind of stacked together, but they were grouped, but they were kind of stacked together in the same thing. I thought for the purposes of this query, it would be more visually digestible, I guess, to see them side by side. So females have their own column and then males have their own column. So I wanted to start with and then I have androgynous scores because I wanted to see the difference between the naming. Like, for instance, if we're talking about the name Devin and there's maybe like 27,000 called Devin, and then 13,000 females called Devin. The gender gap would basically calculate the difference in naming for those two names. And then at the outer, select here, which is just going to take the name, female births, male births, gender gaps, and total births from the androgynous scores, and then ordered by total births and descending. And like the question says, we're going to limit that by 10. Let's go ahead and see what that looks like. Cool. These are, wow, okay. These are apparently the 10 most popular androgynous names over the course of 30 years, right? Because we didn't filter by year. From 1980 to 2010, the most popular androgynous name was Michael. Okay. Interesting. Learn something new every day. Next question here is going to be to find the length of the shortest and longest name, and then identify the most popular short and long names. So I want to start by getting the length of each name. I'm going to have that as name length. Going to get the name, gender, sum of births as total births from the names table and order that by name and gender. And then I'm going to have length extremes as well, because again, we're going to either end of the spectrum here for the shortest names and the longest names. And that's going to come from the name lengths section. And this last bit's going to be the popular extreme names. We're going to take name length, or the name from name length, as well as gender, total births, name length. And then I'm going to join that with the length extremes, where name length is the shortest or name length is the longest. And then that last select is going to tell that where to pull that information from. So it's going to come from the extreme names. I'm going to order by the name length and the total births in descending order. So we're going to start with the shortest name, end up with the longest name. And that's what that looks like. So it looks like the most popular short name is Ty, with 2 characters. And then the most popular long name looks like we have a tie here in terms of length, character length, but we have Francisco Javier, alphabetically anyway. So that'll do it for that question. Finally, we're at this last question, which is kind of a 2-parter. Notice that Michael was a popular boy name, or just a popular name in general. It did appear on the androgynous name table as well. I did see that was a popular name for a few years. So yeah, I wanted to see if I could find the state with the highest percentage of babies named Michael, and the top 5 years where the most Michaels were born, plus the genders. Because, again, there were some female Michaels, apparently. Not that I've ever met one, but let's get into that. Going to start by doing the state totals. Well, the Michaels by state, right? So I'm going to get the state, sum of the births, and that's going to be Michael's births. And that's going to come from the names table, where name equals Michael. We didn't do that before because we weren't looking for a specific name, but now we are. So, and then we're going to take the total by state. I'm going to select the state, sum of the births again as the total births from the name table, but I'm going to group it by state this time. Because again, I do want to find the state where the most Michaels were, or the highest percentage of Michaels were. And the Michael percentages is going to come from state, Michael births, total births. Going to round that, multiply by 100. I got to put the numeric bit in there. Learned that the hard way. I kept getting an error and I couldn't figure out why, but you have to put that in there. And that's going to be as Michael percentage. It's going to come from the Michaels by state, and then I'm going to join the total state in the Michael state with the common state column. I'm going to have it select everything from Michael percentages and ordered by Michael percent. It's going to be descending. And then there's a second select here, which is going to be the second part of this query to see the top 5 years when the most Michaels were born. That is to say, when the most babies were named Michael. So now let's go ahead and see what that's all about. Cool. So it looks like Rhode Island had the highest percent of Michaels. Very nice. The second part of that question was the top 5 years when the most Michaels were born. So it looks like 1980. Oh, that's odd. I wonder why 1980 is after 1981. Oh, because it has more. So it looks like 1981 was the year when the most Michaels were born, and that is as of 2010. That was accurate. Not sure if that remains true to this day, but all right, everybody, that'll pretty much do it for the baby names trends brew. I appreciate y'all sticking around to the end. It means a lot to me. This is my first walkthrough video, but I do anticipate doing more of these in the future. If you're interested in seeing this project in its entirety and seeing other ones like it, the link to my GitHub repo where projects like this will live is going to be down below. Just look for whatever language or tools that you're looking to know some more about. For example, this one is going to be living in the SQL folder because I mostly use SQL in it. Python projects will live in the Python folder, and so on and so forth. My web portfolio and my LinkedIn are also going to be down below if you feel so inclined as to connect with me professionally, which I very much hope you do, as I am in the market for a new job. Thank you again so much for watching. Drop a like and share this with somebody who you think might find it useful. All right, Dennis. Thanks. Take care.